Mechanics static. Balancing the semi-infinite stick. Given a semi-infinite stick, that is one that goes off to infinity in one direction, like this, to the right. Determine how its density should depend on position so that it has the following property. If the stick is cut at an arbitrary location, the remaining semi-infinite piece will balance on a support that is located distance L from the left end. So to solve this problem, we have to write first equation for balance of this stick around this point. It means that total torque must be 0. Suppose that this is the beginning of our coordinate system, x equals 0. So for balance, we need to write equation for torque, which is equal integral from 0 to infinity. And here we have rho as function of x multiplied by x minus L dx, and that's equal 0. Now let's cut this stick in arbitrary position, let's say here, in position z, x equals z. In that case, we have to move this support point to the same distance z, and now write this expression for torque in this term. Torque equal integral from z to infinity rho x, and here we have x minus z minus L dx equals 0. So now to solve this problem, we just need to take first derivative from this expression by z, so d torque over dz, that's equal 0. And how to do derivative for integral? First we need to take derivative for limits and put expression for limits in this thing. So that will be first limits, it's 0, rho equals 0, and the other limit is negative because we subtract other limit. So we have rho in position z multiplied by negative L. Here we have negative. And the other is a derivative from inside expression, inside the integral, which is again negative integral from z to infinity, and here we have rho x dx, and that's equal 0. So let's rewrite this expression in this way, and now we have a simple equation which we can make another derivative. So we have d rho over dz multiplied by L, that's equal negative rho in point z. And the solution for this equation is rho equal constant multiplied by e power negative x over L. So that's the solution for our problem. And there is other way to solve this problem. We can just guess this solution, because if we have a function which with a shift just reduced in the same coefficient, it looks like this: rho from x plus shift a, that's equal some kind of constant, multiplied by rho in point x. And we know that this property only has true for exponential function. So we can write that rho x equal a power negative, let's say, x over lambda, let's say. And now we can put this expression to our formula for torque. So torque equal integral from 0 to infinity from rho x multiplied by x minus L dx. And when we put this expression here, that will be integral from 0 to infinity a e power negative x over lambda multiplied by x minus L dx, which is equal 0. Now we can take this integral, equalize it to 0, and we can find that lambda just equal L.